Geometry A students. This video for the week of June 1st is going to be the last YouTube video. Homework's in the back. This is going to be a slightly longer one, maybe not 10 minutes, might be closer to 20 minutes or so. Um, Not terribly complex lesson, should be pretty straightforward. But this is going to be the last real topic we're going to be going over. As usual, tomorrow you'll have a practice test. I'll send out the PDF. Thursday, there'll be a tutoring session. What time do we usually do it? 12 o'clock, I believe we usually do it. I'll double check the time, but I'll post on Schoology exactly what time once I confirm it. And then Friday will be a test on this stuff. Now, Friday's test is going to be your final test. It's not going to be a final per se, even though it kind of counts as a final, but it's going to be the same amount of points as any other regular test. Just going to be covering this stuff. I may have one or two questions from the past, from older topics, but nothing to stress out about. It's just a regular test, basically. Okay, that'll be on Friday. The last week, next week will be mostly for catch up, and I may put in a few like small extra credit assignments, not worth too much, just a few things if you want to boost your grade up a little bit. Okay, if you're like in that borderline, from a like a whatever your grade may be, if you want to boost it up a little bit. Okay, so let's get started with this one. And so to start this lesson, there's one thing you need to know. Very simple thing you need to know, which you already do know. Triangle. The interior angles of a triangle. What do they add up to? In other words, what's the sum of the interior angles of the triangle? Well, you guys already know this. This is 180. So for example, if I told you this is 50, this is 50, that's 100. So this has to be 80. So 50 plus 80 is 180 degrees. 180 degrees. And that works with any triangle. Okay. They always add up to 180. It could be a triangle like that. It could be a right triangle like this. It can be an obtuse triangle like this. It could be an equilateral triangle like this where it's 60, 60, 60. Doesn't matter. The interior angles are always going to add up to 180. Okay. Now I'm going to show you guys a little something for that too. So interior angles always add up to 180. Um, how about if I do this? What if I draw not a rect, not I'm sorry, not a triangle, but a rectangle? What does that add up to? Well, a rectangle, for example, you know these are 90 degrees. Well, let's just use common sense. 90 plus 90 plus 90 plus 90. There's four 90s. That adds up to 3 degrees. Yeah, but Mr. Arnold, what if it's not a rectangle? What if it's a weird four-sided shape? It doesn't have three sides like a triangle. It has four sides. Again, it's called a quadrilateral. What if it's weird like this? And what if you only give me one of them? You don't give me all the angles. Can we still figure out because a triangle, it always adds up to 180. Is that true to quadrilateral? Does it always add up to 360? And the answer is yes, it does. And I'm going to visually show you why that is. And it's kind of like a game you have to play, a drawing game. You have to cut this rectangle, but you can't cross lines more than once. You can't cross any lines, okay? So I can, from one inch to another, so I can go from this corner to that corner, or I could have gone from this corner to that corner, but I can't cross it again because then I would cross this line. All right, so I'm just going to do it once. Now I'm going to ask you this. What two shapes do you see here? We now see two triangles. Is a triangle a triangle? And what do we know about triangles? The interior angles are 180. So if this is 180 and this is 180 and there's two of them, well then what's 180 plus 180? 60. Same works for this one. No matter what quadrilateral you do, I can go from here to here, or I can go from here to here, doesn't matter. Any way you cut it, guess what? We now have two triangles. We now have two triangles. We know triangles are 180 apiece. So that's it. It doesn't matter what kind of quadrilateral you have. You can always cut it. I can cut it that way to make two triangles, or I can cut it this way. I can make two, obtuse triangles. Doesn't matter. They're each 180, adds up to 360 degrees. So does this work? So we have triangle. That is three sides. We have quadrilateral, which is four sides. So let's think about what's next after quadrilateral. Well, how about something that has five sides? I'm just giving you the common polygons here. I don't do every single side. I'm not going to go till 1,000 sides. Well, what do we call that? I don't even know. Okay. But I'm just giving you the most common ones. Well, the next one is pentagon. A pentagon has 5 sides. So figure that out. So real quick, actually, let me make this a little bit more neat. Let me make this a little more neat. Triangle. Make this a little more neat. Has 3 sides and it's 180 degrees. Okay. Quadrilateral has 4 sides and it's 360 degrees. Now we're doing a pentagon, which has 5 sides. Let's test this one out. The pentagon. Now let's play that game again. Let's try to draw triangles in this. Okay, I can go from this corner to that one. Beautiful. But I can still do one more here, okay, without crossing lines. I can go like from here to there, can't I? Or from here to here. That's fine, but I can't do it again. So now I have, let's see how many triangles I have. I have 1, 2, 3 triangles. So remember, if each triangle is 180, that's basically 180 plus 180 plus 180. A shortcut for that is just saying, hey, just do 180 times 3 on the calculator. 180 times 3 on the calculator. And that's going to get you 540. Perfect. Cool. Moving on now. After a pentagon, we have a 6-sided shape, and the 6-sided shape is called a hexagon. All right, let's try a hexagon. Let's try a hexagon. 1, 2, 3, 4, 5, 6. Okay, hexagon. Let's play the game. From there to there. From there to there. From there to there. You can see I've done this quite a few times, so I know how it works. 1, 2, 3, 4 triangles. Now, I'm going to show you a little easier way of doing it. If this is 4 triangles, each triangle is 180. So we're going to do 180 times 4 to get our answer. And that's going to give us 720 degrees. Okay, looks good to me. Now, the next most popular one you're going to see, we're going to skip 7 sides, okay? You don't see it too often, though it's not uncommon. It's just, next one you usually see is an octagon. And you know octagon because the octopus has 8 arms, okay? So octagon has 8 sides. Now, I'm going to stop right here for a second. I'm not actually going to, you know what? I'm going to draw it. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm not actually going to sit here and draw the triangles again for an octagon. Okay, it's going to take some time. And what if I didn't ask you for octagon? What if I said decagon? A decagon is like a decade. A decade has 10 years. Okay, can you imagine? That's going to get crazy. That's going to like take a long time drawing all those lines. What if you mess up? So I'm not going to rely on the lines. The lines were basically just to show you something, to show you how it works. But now we're going to rely on noticing a pattern. Let's notice a pattern. Triangle has 3 sides, but it's only really one triangle. 1 times 180, 180. A quadrilateral had 2 triangles, and it was 360. A pentagon, when we cut it up, was 3 triangles. Hexagon. So this was, a triangle is only 1 triangle times 180. A quadrilateral had 2 triangles if you cut it up, times 180. A pentagon was 3 triangles times 180. A hexagon was actually 4 triangles times 180. Now, what's going to happen with an octagon? Now, here is, now, before you say 5, no, that's not the right answer, okay? Here's what's happening, you guys. What is 3? The number of sides of a triangle is 3. What's 3 minus 2? 1. Take a hexagon. What's 6 minus 2? 4. What's 5 minus 2? 3. 4 minus 2? 2. What's 8 minus 2? 8 minus 2 is 6. So in order to get the interior angles for an octagon, I'm just going to do 6 times 180. That shortcut, when you subtract the number of sides by 2, that tells you how many triangles. And I guarantee you there'll be 6 in here. Ready? Watch. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 4, 5, 6. There's 6 triangles there. 6 times 180 is going to give us our answer, which is going to be 1080 degrees. Okay, so that's the shortcut. And the way the rule looks is like this. The way that it goes n minus 2 times 180. What that means is n is the number of sides you have minus 2. So you subtract the number of sides you have, subtract it by 2, and then you multiply by 180. So let's try 10 in there. The decagon is 10 sides. So let's do it. 10 minus 2 is 8. 8 times 180 is going to be it's going to be 1,440. Sorry, what my math? Okay, 8 times 180 is 1,440. So, well, yeah, but I like drawing the lines. You know, it's easier for me. I'm just going to do that from now on. Okay, well, decagon has 10 sides. Octagon has 8. What if I said this? Find out for a 17gon. That's a short way, or a 17-sided polygon. 17-sided polygon. I don't know what the name for a 17-sided polygon is. There's probably a name. I don't know what that name is, okay? I don't expect you to know too. But I'm telling you a shape, a polygon that has 17 sides. What would the interior angles, the sum of the interior angles be for that? Okay, what would the sum be? You don't need to draw it. No one expects you to draw it. It's like very, very difficult to draw. So what you do is you just do the number of sides, which is 17, subtracted by 2, that's going to be 15, and just multiply 15 times 180. Okay, I don't know what 15 times 180 is, so I'm just going to have to use my calculator. 15 times 180 is equal to 2,700. So something that has 17 sides, it'll be, so it's a 17gon. That'll be, what did I say? 2,000, I just said it, 2,700. 2,700 degrees would be the sum of all its interior angles. That means if you add up all the interior angles, boom, 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 all 17 of them, you'll have 2,000. And it makes sense. The more sides you have, the more angles you have. The more angles you have, the more the total degrees is going to be. A triangle only has 3 angles. It adds up to 180. It's not that much. A hexagon has definitely more. It adds up to more. Okay? So that's kind of the understanding. That's kind of the gist of how interior angles work. Okay? I want to add one more thing to this though. Okay? So, like we said before, a triangle can look a bunch of different ways. You can have a triangle like this. You can have a triangle like that. You can have a triangle like this, like that. You can have a bunch of different looking triangles, yet they all add up to 180. All because a triangle adds up to 180 doesn't mean all the angles are the same. They're all 60, 60, 60. No, this one could be 90 here. It could be 70 here. It could be 20 here. Okay? We don't know what each angle individually is going to be. We just know that the total is 180. But there is one time when we actually do know. If I were to tell you an equilateral triangle is where all sides are equal. If all sides are equal, all angles are equal. So if I told you this is 180 degrees, which you know a triangle is 180, but all the angles are the same, it has to be 60, 60, 60, because they all have to be the same angle. So it's 60, 60, 60. So how do you get that mathematically? You basically do 180 divided by 3, because a triangle has 3 sides. Okay, you do 180 divided by 3. Now, there's a word for this. Equilateral is one. But a more common word that we use is regular. So if I ask you to draw a regular triangle, you don't draw those fancy triangles. You draw an equilateral triangle. If I ask you to draw a regular quadrilateral, you basically draw a square. Okay? If I ask you to draw a regular pentagon, you would draw a pentagon where I didn't draw it correctly, but where I can't draw a regular pen, where all 5 angles are the same. A regular hexagon would look a terrible job. Oh my god, terrible. It doesn't even look like a regular. But a regular hexagon theoretically would be one where all 6 angles are the same. It wouldn't look like a weird distorted hexagon. It wouldn't look like a weird distorted octagon, pentagon or octagon. All would be the same. So you can just divide it by that number. So how much would each angle in a regular triangle be? 60 degrees. How do I find each angle in a quadrilateral, regular quadrilateral? Take that divided by the number of sides. So I'm going to divide 360 by 4. That's going to give me 90. How about in an octagon? So I'm going to take 1080 and divide it by 8. 1080 divided by 8, because an octagon has 8 angles. So that'll be, each angle is 135 degrees. Okay, so that's answering that question. All right, last topic. So we are going to end at around 20 minutes, okay? So last topic here, those are interior angles. Well, how about exterior angles? Oh, whoops. I did not want to erase that. Triangle, quadrilateral. Okay, now how about exterior angles? And to do exterior angles, exterior is very easy, actually. I'll give you a little example here, okay? Now, if we were in the classroom, I'd have you guys actually do it with a protractor and all that, but let's take our regular triangle that is 60, 60, 60. And what I'm going to do is I'm going to extend this regular triangle. What do I mean by I'm going to extend it? I'm going to go like this. I'm going to extend this to make an exterior angle. Remember, these are interior because they're inside the triangle. Exterior is angles on the outside. So I just made an exterior angle right over here. This little angle right here. We don't need a protractor for this. We already know what it is. Because think about it. Remember, straight line is equal to 180. So if this is a straight line, that's 60. What is 180 minus 60? We are going to be left with 120 degrees. Okay, so is that the only exterior angle in a triangle? No, there's more. I just drew in right there. Here's another one right here. And again, same with this one. If that's 60 degrees, the one next to it supplementary must be 120 degrees. I'm guessing you're seeing the pattern here, right? And then so I'll draw another exterior angle, which is the last one, the third exterior angle, because remember, it's a triangle. It has 3 interior, 3 exterior. And so this one right here will also be 120 degrees. So the question is this: what is the sum of the exterior angles? What do they all add up to? Well, let's do it. 120 plus 120 plus 120, that adds up to, so this is interior, and exterior is going to add up to 360 degrees. Exterior is going to add up to 360. Simple as that. Okay. Now, take a look at this. So, wait a minute. So what's the formula? Do I have to do that every single time? No, you don't. Because watch this. I'm going to go with a pentagon right now, okay? Go back to the regular pentagon. Let's go back to regular pentagon. Okay, not the best regular pentagon. Does not even look like a regular pentagon. But a pentagon is 540. And if I divide 540 by 5, because it has 5 angles, that's going to get me 108. So I'm telling you this is 108, 108, 108, 108, 108. And I'm going to make exterior angles just like I did with the other one. 108. I'm going to do 180 minus 108. That's going to give me 72. Guess what? This is 72. Guess what? If this is a regular pentagon. 72, 72, 72, 72. Now I want to add up 72 1, 2, 3, 4, 5 times. And you know what that answer is going to be? That answer is. Guess what, guys? That is going to be true with every single polygon. Doesn't matter how many angles it has, how many sides it has, the exterior angles will always, always add up to 360. No calculation needed. It always adds up to 360. Okay, guys? All right, so that's it. Let's flip over for the homework problems. Okay, Those are the practice problems. You got number 1, find the sum of the interior angles of an octagon, that polygon right there, and a 23-sided polygon. Next, find the sum of the exterior angles of a pentagon and that. And then lastly, find the measure of each interior angle of a regular 17-gon. Okay, so that's it, guys. That's the homework. Link will be available in the material section to turn in the homework for this. Okay, thanks, guys.